Okay, so picture this. You're parched, it's a scorcher outside. You open your fridge, reaching for that ice-cold water.
Oh, yeah.
And that feeling, that instant relief when that cold hits your hand,
Yeah.
you
Oh, yeah.
just expect it, right?
Total given.
But have you ever actually stopped to think about what's going on in there?
Right, like how it actually works?
Yeah, how that box in your kitchen is defying the laws of physics practically.
Defying is a good word for it.
Today, we're diving deep into the world of refrigeration.
Ooh, this is going to be good.
And spoiler alert, your fridge isn't actually making cold.
Wait, what?
It's removing heat.
Well, hold on. That's like saying you warm up a room by taking out the cold.
I know, right? It sounds kind of backwards, but trust me, by the end of this deep dive, it'll all make sense.
Right, I'm all ears.
So to correct this case, we need to understand something called the refrigeration cycle.
Okay, so is this like a secret society thing or
Not quite, but it does have 4 key players.
4 players, huh? This is starting to sound like a game.
It kind of is a game of physics and engineering, and we're going to break it down step by step.
All right,
Meh.
break it down for me.
So even if you've never even thought about how a fridge works, you'll leave here a refrigeration pro.
Challenge accepted.
And you should care because this process isn't just about keeping your beer cold.
Oh, yeah.
It's way bigger. It affects everything from how we store food to developing life-saving medicines.
Wow, okay, you've got my attention.
All right, so first things first, we got to meet the star of the show, the refrigerant.
Refrigerant sounds important.
It is. Think of it like a heat transporter, a special fluid that can switch between liquid and gas.
So it's like a shapeshifter of the chemical world.
Exactly. And here's a trick. When it changes from liquid to gas, it sucks up heat like a sponge.
Like when you sweat and it evaporates, cooling you down.
You got it.
Yeah.
And when it goes back from gas to liquid, it releases that heat.
Clever.
This constant absorbing and releasing of heat is the engine of the whole process.
So the refrigerant is like our little heat courier.
Precisely. Now we need something to keep it moving. And that's where the compressor steps in.
The compressor sounds powerful.
It is. It's the heart of the system pumping the refrigerant round and round.
Okay, so this is where the action starts.
You know, the refrigerant enters the compressor as a low-pressure gas. It's just picked up heat from inside the fridge.
So it's like our courier is coming back from a pickup.
Exactly.
What happens next?
So the compressor's job is to squeeze that gas into a much smaller space,
Crushing it down.
basically. And when you compress a gas, 2 things happen.
Lay it on it.
Pressure goes up and temperature rises too.
Ah, so like when you pump a bike tire, it gets warm.
Perfect analogy. So our cool gas is now a hot, high-pressure gas ready to dump that heat.
All right, so where does it go?
Next stop is the condenser. Those coils you usually see on the back of your fridge.
Sometimes there's a fan there too.
Yeah, that's to help things along.
Hmm.
Now imagine that hot, high-pressure gas flowing through those coils.
Got the picture.
The coils are exposed to the room air, which is cooler than the refrigerant.
All right, so heat always travels from hot to cold.
Exactly. And as the hot gas in the coils meets that cooler air, it starts to lose heat.
So the heat is escaping the refrigerant.
And as it cools down, it condenses, it changes back from a gas to a liquid.
Like steam turning back into water on a cold window.
Exactly. And here's the thing, that heat that was originally inside your fridge is now being released into your kitchen.
That's why it feels warm behind the fridge.
You got it.
Kinky.
So we've dropped off the heat, but our refrigerant's journey isn't over yet.
There's more.
Oh yeah. It's a high-pressure liquid now, but still kind of warm.
So it needs to cool down more.
To do its job properly. Yeah. And to do that, we need the expansion valve.
Expansion valve sounds important.
Very. It's basically a tiny little opening that the refrigerant is forced through.
Like a bottleneck.
And when that high-pressure liquid squeezes through this tiny space, the pressure suddenly drops.
And when pressure drops.
Temperature plummets, too. It's like when you spray a can of compressed air, it gets super cold.
I've always wondered about that.
So our refrigerant goes through this tiny valve, pressure plunges, temperature plummets, it turns into a cold, low-pressure mist.
Ready for action.
Exactly. It's now ready for its final mission inside the fridge.
Bring on the cold.
And this is where the evaporator comes in. Those coils inside your fridge, the ones that get frosty,
Okay, so our cold mist goes into the evaporator.
and those coils are surrounded by the warmer air inside your fridge.
All right, so what happens? More heat transfer.
You bet. As that super cold refrigerant flows through the evaporator, it starts absorbing heat from the air inside.
So it's like a heat vacuum.
And as it absorbs heat, it starts to evaporate, turning back into a warmer, low-pressure gas.
Like this sweat example.
Exactly. The The refrigerant is soaking up heat from the fridge, cooling the air down.
So the refrigerant is getting warmer and the fridge is getting colder.
Now you're getting it.
I feel like a refrigeration genius.
You should. And guess what?
It goes back to the compressor.
Bingo. That warmer, low-pressure gas leaves the evaporator and heads straight back to the compressor to start the cycle all over again.
It's a never-ending loop.
Exactly. This cycle runs hundreds of times every hour, constantly moving heat from inside your fridge to the outside world.
And all this is happening silently behind the scenes.
It's pretty remarkable, and it's all thanks to this closed system with the perfect amount of refrigerant.
Keeping everything balanced.
Now, of course, the design of these components is important too.
Right. They need to be tough enough for the job.
The compressor needs to be strong to handle all that pressure,
Hmm.
and the coils need to be good at transferring heat.
So what are they made of?
Usually copper or aluminum because they're great heat conductors.
And those fans we talked about.
They help circulate air around the coils, making the heat transfer even more efficient.
Clever.
So let's recap.
Hit me.
We started with the compressor squeezing that refrigerant, making it hot and high pressure,
Right, then it goes to the condenser.
where it releases that heat and turns back into a liquid,
Then the expansion valve,
where the pressure and temperature drop.
turning it into a super cold mist.
And finally, the evaporator, where it absorbs heat, cools down the fridge, and turns back into a gas.
And the cycle repeats.
You've got it down, Pat.
It's all about moving heat, not making cold.
That's the key takeaway.
Mind blown.
All this is happening in that humming box in your kitchen.
Keeping our food fresh and our drinks cold.
And it's the same principle behind so many other things.
Like air conditioning.
Exactly. From keeping your car cool to preserving organs for transplant.
It's pretty amazing when you think about it.
It's a testament to human ingenuity, this whole process of manipulating heat.
We really do take it for granted.
We do. So next time you grab something from your fridge, take a moment to appreciate the science behind it.
To that little refrigerant working tirelessly.
And here's something to ponder on.
I love pondering.
Now that you know fridges are moving heat out, think about the bigger picture.
Okay, go on.
What happens to all that heat? Where does it go?
That's a good question.
And with the planet warming up, how can we make cooling more efficient?
Yeah, can we make it more sustainable?
These are the challenges engineers are tackling right now.
It's a cool field to be in.
Pun intended.
Uh-huh.
That's all the time we have for today's deep dive, but hopefully this has sparked your curiosity.
It definitely has mine.
And who knows, maybe it's even inspired the next generation of refrigeration innovators.
Go change the world.
Thanks for listening, and until next time, keep those fridges humming.
And those drinks cold.